Hey there, this is Kardall, and today's topic is Cardano faucets. The reason is we had some messages on YouTube and in Discord channels of people who want to know how to set up their own faucet because I did the videos about the faucets and all that kind of stuff, and so I figured let's just do a walkthrough. Now, the majority of this stuff is similar to another video that I made setting up a Cardano development environment, which I will put a link to in the description or a card up top. But this is going to be a little different. I believe in that one I used the Cardano CLI.js, the JavaScript NodeJS kind of interface for Cardano Node. We won't be using that in this. This is strictly for a faucet. So it's going to be a little different. So first we have to set up the node. So this is going to be pretty much the same way as the other one was. So installing Ubuntu 2004, and we'll just give it a username. I'm not going to do any advanced security stuff or anything like that because it's just a test thing, and make sure that we type the password right. And this is going to be faucet example, and yeah, that we'll put it on the main drive. All right, so it's going to be a single drive, and we're going to make this 100 gig. And we'll say next, and then we're going to customize this hardware. Now, because it is a pain to deal with, we're going to give this 4 cores, and we're going to give it 16 gig of RAM. And we're going to bridge and replicate our physical adapter, and we're going to close. So, you know what? No. Just for this example, we'll do 8. And we'll do 6 cores. Just so that this will go a little faster. You'll have to adjust all the stuff according to the system that it's being installed on. But so the fun part about this VMware, the easy setup or easy install that they have here, it detects that we're installing Ubuntu, and it has a setup script, if you will, that will automatically skip through a lot of the configuration of Ubuntu, like setting your locale, your region, your time, all that kind of stuff. It does it automatically. So it's going to do a check of the ISO and all the files and making sure that they are correct and not corrupted, etc., so it can continue. And once that's done, it's just going to breeze its way through the install process, and yeah, we'll just come back when that part's done. All right, so while this is doing the install, I figure it'd be a good time to just chat about what we're actually going to install during a faucet. So the way that the Pocket Change, the Pocket Towns PTC currency that we use, the way that that faucet works is you send it ADA, and then it takes whatever minimum, maximum amount that is set up, and it returns to you the equivalent value of Pocket Change. The method at which it does this is we have to have, number one, we need a relay on the system. So we have an actual Cardano node, and its access to the network so we can do transactions and such. It also has Cardano Wallet, which is the Cardano wallet interface for the blockchain, so you can create a wallet with an API interface that you can use to monitor that wallet for incoming, outgoing transactions, etc. And that's what we query the transactions list for. And that way, anytime it gets some new transaction that we don't have recorded, it will process it according to whatever it is. So if it's just someone sending ADA and we don't want to, we want to like send them something like Pocket Change back, we would just send them an equivalent amount of the Pocket Change based on how much the transaction says was received. So, 10,000 or 10,000, 100 ADA would be like, I was like 50,000 Pocket Change or something. I can't remember what the ratio is. It would be something like that, right? So you would basically you could make it do anything you want. You just have to know what you want to accept and what you want to send. Um, for this example, we're going to use a third party because I have not set up the minting for a node. I haven't got it to work with Cardano CLI. So right now, like Pocket Change or Pocket Town, we're using NFT Maker Pro right now to deal with our land sales and the paper dolls and all that stuff. So they have an API that you can use to send a random NFT. So you would create all of your NFTs on a project with NFT Maker, and then you would put all the metadata, everything, get all that set up for the project, and then you would use that project ID and your API key from them to do a web request with that project ID and tell it I want to give one of random things to an address. So we have to use the Cardano wallet to get the address from the transaction in order to send to NFT Maker so that it knows who to send whatever it is back to that person, whatever NFT that you want to do. It could be anything. The land and such even has royalties on it for subsequent sales after the initial minting. So you can do all that kind of stuff with it. It's pretty cool. But the first thing we got to do is get the relay set up. So it's pretty standard nowadays. I pretty much only use the guild operators, which is a bunch of the operators of the larger pools. They created this system called CNTools, and it basically makes everything a lot easier to set up a node on a Linux machine. It has scripts and automatically compiles things. The catch with the nodes and stuff like this, the way that we're doing this, you want to have 16 gig of RAM in this machine. If it was just a node, it would probably be okay to run it like 12 gig with a 4 gig swap file or something like that. But I'm gonna do a 16 gig of RAM, and then I'm gonna increase it to a 4 gig swap file because I believe it's 512 meg to by default. So I'm just gonna increase the swap file to 4 gig, and once we're done setting that up, getting all of our system settings, the IP addresses and everything set up, we'll go ahead and reboot the machine and then start installing as we see fit. So in addition to all that other information, we're going to use the following sites, and I'm going to put the links to these sites in the description. This is the guild operator script. It's got basic step-by-step instructions that you can just copy and paste and stuff. We'll go through this as we do the install, but this is how to install CNTools, which includes the node and a bunch of other services. This is how we increase the swap file size on Linux, so it's permanent. And we're going to do these before we do the relay itself. We also have the Cardano wallet, so we're going to install this as well. This is the API interface to create and manage and monitor a wallet. This is our router, and I'm not going to show that, but it's got the port forwards, so make sure you do that. And then you have your Open SSH server, which is usually a good idea to set up because yeah, you'll want to have SSH on your server. Just as a general guideline, it's the best practice. I'm not going to go over setting up keys for it because yeah, this is just a demo, but you'll definitely want to do that so that it disables the username password login for SSH, so that you have to have the security key in order to go into SSH. So make sure that you do that if you're going to be putting this in public domain, because you do not want anyone to gain access to your server. That would be bad, okay? Yeah, so here we go. So it's restarting. We're going to come back into the OS, and we're going to do a couple of things. First thing we're going to do, we're going to update everything. And then we are going to do our, let's see, what are we going to do? Okay, let's do the swap file first, right? And then we're going to do the SSH, sure, and then we will do the relay and then the wallet. Okay, we got our order of operations set up. So this is our order: Swapfile, SSH, relay, wallet. That's what we're going to do. And if you make those 4 tabs in those orders, you can follow along. All right, so here we go. We sign in. And once it's logged in, we're going to maximize so we can get a full desktop. Alright, and we skip all this stuff, don't send info, and next, and done. Okay, so we're going to right click the desktop, open in terminal, it gives us a terminal window, and we're going to go sudo apt update, and, oh, come on, and sudo apt get update -y. And we give it our password. Not upgrade, that's supposed to be upgrade. We'll let this run. Sudo apt get upgrade -y. Alright. So there's that. So let's go ahead. I'm going to pull up the Swapfile thing, and we're going to go through all of this stuff. Alright, we're almost done. There's ManDB. Okay, so let's actually first thing here, let's just go ahead and change our network settings while we're at it. So, because it's gonna stop downloading soon. So what we'll do is we will go here and we're gonna give it a address. This is the IP that I have forwarded all the ports that I need. Port 22 for SSH, as well as I think 3005 was the one that I spent. I forwarded, and it's like 3005 to 3030 for the demo, whatever one I give for this development rig. So that way I have some ports that I can utilize for different projects. Okay, and we enter in Google for DNS, and I'm going to actually wait until this is finished to apply this. So there we go. So now we're going to apply, turn it off, turn it on, and actually we will disable IPv6 because I don't want that right now. Okay, so there we go. All right, so now let's do the swap file. So the swap file, we have to first swap off A. So we're going to disable the current swap file. And we're going to go, the input file is dev0, and then the output file is swapfile, and the block size is 1 gig, and the count is 4. So we're going to do 4 gig swap file, and that should be plenty for this machine. No typos, good. This is a lot nicer when it's running on a regular computer. And there's Ubuntu's. Yeah, you don't have to. Alright, there we go. So now we're going to sudo make swap file. And then we're going to sudo swap on swap file. There we go. And let's do the SSH thing while we're in here. Sudo apt install open SSH server. And we're going to do curl as well, because we need curl to do the relay anyway, so we might as well do it here. And we will make sure that the SSH is running. Systemctl status SSH. We're running. Cool. All right. So now let's go ahead and do the restart here while we're at it. Start. It's small. Sign in. And we will just do an apt update just in case. Because we did get that update alert. I just want to make sure that nothing was being locked. So we'll open a terminal, sudo apt update, password, sudo apt get upgrade, Okay, we're good. All right, so now let's go ahead and we're going to follow the guild operators thing here. And we have to do the copy the we'll just open it in here so we can just copy paste it. Then we don't have to worry about a whole bunch of stuff. So we get rid of this and we go search for guild operators. And there's the back. And we go to basics. And let's bring our terminal window over here. And so what we do is we copy this one. We've already installed curl previously, so this should just all work like just awesome. There we go. So that is the install script for this entire thing. So now what we're going to do is we're going to run this prereqs, right? And this is going to install all of these things that it needs to build the Cardano node. All of the background, libsodium, and all that kind of stuff is going to go in here. I think it puts libsodium in. If not, it puts it in the install script for the node itself. But this is just basically everything it needs to make sure that you have GHC, which is a compiler for it, so that it can compile the node. Just general things it needs to complete everything properly. And yeah, the next step after this is we got to do this whole amazing line right here. Alright, here we go. Bash RC. Alright, so now we'll copy this and we are going to go in here and we're going to pull the tags and we're going to do get fetch tags all, and then we're going to get checkout version 1.32.1 because that's the one that I'm used to. I guess there was a few issues with the newer versions with guild operators, and I don't have to update it yet, and so it's not like when they did the 1.31, I think it was, or 3, where it was like if you didn't upgrade to 1.31 and you were on 3, at that point you couldn't mint blocks or something like that. There's not anything like that with this version versus the newer version, so I'm just gonna stick with this one for this build. And yeah, and if things change, just make sure you do keep this node updated. It's nice to have updated nodes on the network. Yes, okay, so now we've got the checkout. So now we're gonna go cnode home scripts cabal build all. And then this is going to take a while. And this is going to compile all of the link libraries for the software and just make your Cardano node and your Cardano CLI programs. As well as you get your copy of Cabal, which will need to do the Cardano wallet. When we're done, we're just going to run these two commands just to make sure that these versions are the ones listed here, and should be good to go. So we will let this hammer its way through the install, and yeah, let's actually, while we're waiting, we can clone this wallet while we're at it. So we're going to go install Cardano wallet. And we might as well clone this into the Git. So we'll go back a directory. And we want to do here, this. Actually, no, we're not going to do that one. We're going to do this one. We already have a Git folder in here, so we might as well clone the GitHub while we're at it, and then yeah. This thing is just hammering away. Okay, there we go. So now we'll be ready to do all of this stuff when this is done. So we will let this do. We don't want it to run out of memory while we're doing this. Compiling does use a lot of resources, so we'll do them one at a time. just so that they are kind of happy with the system and we don't have to worry about running out of memory. And if it does happen, you'll just have to recompile. Things that are compiled already that it detects no new changes, it'll just skip them and use them, so you don't have to worry about wasting too much time. But it's still a hassle to have to recompile the whole thing, especially the node. The node takes a while. Probably the longest to compile is the node. It's just got so many moving parts in it that it's insane. I did have a video where I showed how to use the Windows version of the dataless wallet as a node in like this environment and do uh, queries on the blockchain with Cardano CLI.js on Windows, but I had to manually change all of the kind of Linux functionality into Windows. So wherever it was doing directory searches and or like any commands on the command line and stuff like that, it only has Linux commands, so I had to rewrite them as if it was the OS was Windows and do specific things. Some of it worked. I didn't actually go any further. It just didn't seem like a feasible project for me to take up my time with at this moment. But the faucet was probably the most important thing because we needed one for Pocket Town, and this is the, I guess you could say, the culmination of all the work that I've done on it so far with all the knowledge that I've gained, because there really isn't anything about this on the internet. There's lots of documents and stuff, but there's no like guides on how to set up like faucets and stuff. Lots of node setup guides out there, how to do transactions manually and stuff like that. I don't like doing manual transactions. I use CNTools for all my transactions if I have to. Even saving them, the transactions on a cold machine that's not on the internet. You can create the transaction and then send that transaction to like sign it and everything, and then send it to your block or your relay, and use CNTools to send that transaction to the blockchain, and then you don't have to worry about having your signing keys on that machine. So yeah, it's very nice to have CNTools. Makes a lot of the security things pretty handy. You can even, if you do put your keys on the device, you can actually encrypt them, and then you can take them off and store them in a cold machine so that's not hooked up to the internet, and then you can put them back on the CNTools directory, decrypt it, do your thing, and then encrypt them again and remove them. And you do it all at once so that you don't have to leave them on the machine. You're not supposed to leave them on the machine anyways. So yeah, there's some pretty good practices. Guild Operators does have a Telegram. You should go and check that out. I believe it's on the Guild Operators page somewhere on here. And you can go and chat with the guys who develop it. They're all pretty friendly, easy to talk to. They're busy, but if it's a huge question, there's usually a lot of people in there that have either encountered it and solved it and can help you out, or if it's a development issue and stuff, they're usually really good at responding quite quickly. So yeah, highly recommend checking out that Telegram. So we'll let this go, and we'll be back in a few minutes. And that reminds me of something we have to do. We have to turn off the standby. Power, blank screen, never. There we go. So as a little side note here, while this is compiling and doing these things, and I had mentioned the resources that it uses, so we're just going to open the system monitor here. And what you'll see is it's using like 2 gig just to compile the node. The node itself is probably going to use all of the RAM. So like here, it just dumped up to 5 gig. Like it bounces quite a bit. So if I tried to run this on an 8 gig system and compile both at the same time, this would probably hit a memory limit at some point and it would error out. So that's just a really good example of why it's important to compile these things one at a time. The CPU, you can see it bouncing between 100% on some of them are quite high. But yeah, it's pretty intensive to compile this software, so you want to make sure that your system is beefy enough that it's going to be able to actually uh, be able to actually function while it's doing this and not lock up, have some errors or anything like that. So that is just a little side note, an addendum, if you will. Okay, so this part's done now. So what I'm going to do, let's go ahead and do this Cardano node version, Cardano CLI version. And we've got 1.32.1 for both, so we're all good there. So let us go into the CNode home scripts, and we're going to edit the environmental variables, and we're going to change our port to the one that we have open for this particular development machine. And yeah, let's set the socket just in case. And we will exit that after we save it, and then we're going to nano the glive view. Oh wait, sorry, it's gliveview.sh. So this is the shell, and we're just going to give this a name here, so we know what, when we look at a screen, that we know what we're looking at. So this is the faucet example relay 1. All right. So that part's done. That should be ready for us to go. As soon as this is done copying over, then we should be good. But we are going to do this now. So we're going to do cabal build all. And we're just going to let this go through all the way and make sure there's no errors when it compiles. And once that's done, we will do the install, and it should be good to go. And we can start synchronizing the wallet or the blockchain. Just waiting for this to finish. I popped up the resources here so you can see what this compiles like. So it's using a lot more CPU than the other one. It's pretty steady, whereas the other one was fluctuating between the cores. This one is using not as much memory, but yeah, it's definitely hammering the CPU a lot harder than the rest of it. So oh man. You know, it's times like these that make me wish that I had a thread ripper. I could throw like 32 cores at a virtual machine, get like half a terabyte of RAM, and give the machine like 64 gig and just throw everything at it. Probably could compile everything all at once on that machine. It'd be great. But that's for future me. Gotta save up quite a hefty sum of money in order to afford one of those. I think the processors are around $5,000 or something, 3 to 5,000. I can't remember how much they were. That's pretty crazy. But I mean, if you're doing a lot of virtual machines and stuff like that, and you want to, you know, segment out your processor to do specific things, like have a virtual machine with like maybe you're gonna run a DB sync on it so that you can do your own blockchain queries, like Blockfrost does it, and Koios is another one. They have a REST API for the blockchain. They run a DB sync server, and you could run your own and make your own queries and do your own custom things to it. So, I mean, you could totally conceivably run your own server on a Threadripper build and use it for development at the same time. I mean, they're like 128 cores or something like that. Alright, it is done. And I saw it spiked up to almost 9 gig of RAM. That's pretty insane. Alrighty, so we're going to go ahead and do the relay now. So let us go ahead and deploy it as a system service and enter our password. And no, we won't do the updater. We'll just use the default ones for now. I don't need to block performance. All right, so I'm pretty sure that I did this already. It's been a while. Yes, I did. All right, so all those files should be done. So sudo systemctl start cnode, sudo systemctl status cnode. We are running, so now we can go like this. Let's go ahead and make this a little bit smaller so that we can runglive view. And we'll just call it. Let's go R01. There we go. There we go. All right, so faucet relay. Okay, well, we're at 11. Whatever, that doesn't matter. So now this is going to do all of its little synchronizing things, and it should just hammer its way through. All right, so 9.5 minutes, and we're at 268. So don't have too much further to go. Shouldn't be too bad, and yeah, we're just gonna let this run probably overnight, and hopefully tomorrow at some point it'll be done and all synchronized, and it won't be a whole day for you, but it will be for me, and we'll come back when this is done. Alright, so what we have to do in order to get this faucet to work is we have to actually install Node.js on here. So I'm just going to do this in the faucet folder because that's what's open. We're going to do apt install Node.js and npm. And enter our password, and this will install Node.js so that we can do all the fun stuff in regards to the actual faucet. Alright, so now that that's done, the other thing that's a good idea to install is PM2. So we're just going to go npm install PM2 latest globally, and this will install. If this has an error, I might have to do sudo, but basically the PM2 is a way to run a Node.js as a service, and just by adding it to your system, you should be able to automatically start it. So if you reboot the system, at least the API will restart. Yeah, I'm gonna have to do sudo. There we go. Alright. So now that PM2 is on, we can do PM2 status, and there's nothing loaded in here, so we can't really do anything, but it tells us some interesting things. So we can make it auto boot at server startup by doing this PM2 startup, and then anything that we do and add to this, copy this, paste this command. There we go. And yeah, so here's how you remove it. You do save, so you would start it, so you do like PM2 start faucet.js or whatever, right? And then you would do PM2 save, and that saves the running processes so that that's what it starts every single time the system reboots. So that's just an easy way to do the like a service for a Node.js on a system. All right, so let's go ahead and look at this code here. So I've got Visual Studio set up as a favorite on here, so we can just run this. Now you'll want to make sure that you do install Node and everything before you start really working on this, because you can actually run everything from inside the editor. It has a terminal, and you can just start the server, etc. right from here. So let's open the folder. And we're going to go into the faucet one. This is a exact replica. I believe I've said this before, but it's an exact copy that has been stripped all of the important details or sensitive data from this, so that it's just kind of a skeleton, and it's just like a basic example of what it can do. where you could accept ADA and send back a token in some amount. So it's just an example, and you can modify this code to your whatever you want. I'll hopefully have a link to the GitHub down below, or a download for the source code. So the important stuff is the package. So we have our dependencies, which is just Axios. That's just a really easy way to do web requests and stuff. And that is the only real dependency. It's not using Express. If you do use Express, you would install it, and that would also allow you to basically make an API, so you could add queries in to get like wallet remotely, like wallet status and stuff like that, or keep a log of how much you've sent and how much you received, and report that, etc., etc. That would be totally up to you to implement. The other part is the TX template. So this is the template of the transaction body that you have to send to Cardano Wallet in order to send something. So if we had, in this case, the pocket change, we'll use it as an example. You would put the pocket change policy ID and the hex name of pocket change here, and that's pretty much the two important parts. The rest of it is populated from within the faucet itself. So the address here is the sender, and the quantity is how much of this token that we're going to send back. So we'll go around in a sec, but I'm going to show you where you can find this information. So I just have pocket change here loaded up in Cardano Scan. And you can see the policy ID right here. So we would put that in the policy ID. And then the asset name here, so you're looking for this part, this 505443. This is the hex version of PTC. So this is what it's expecting as the name of the token on the transaction. So that's what you paste in there. So policy ID, hex name, and we will continue on with the configuration. So in here we have all of the basic data that we want to store about our transaction. So we have our spending phrase for our wallet in here, and then we have the fee. So this is how much the fee for how much ADA is being sent in this case. Once again, this is as if we're sending pocket change for ADA, like the pocket change faucet. So we would have a fee of 2 ADA that we subtract from the amount, and then that's how we calculate how much pocket change to send back. 1.5 of that 2 is to go back to the sender so that we can send their pocket change with it, and then the half ADA is just for processing. So here we have our minimum ADA to send, and the maximum ADA to send is 500. So anything outside of these bounds is considered a donation as far as this faucet is concerned. If you send more than 500 ADA, it will send 500 ADA worth of pocket change, and it will keep the rest. So the token value per ADA is how we're going to calculate how much of the token to send back. And the wallet ID is the ID of the Cardano wallet, which I will show you how to get find that information once the wallet is all synchronized, which it's still doing right now. It's actually still synchronizing the relay or the blockchain right now. So it'll be a little bit until we get to that point, but this is just the overview. Then we have the test DB. This is a list of every single transaction and its current status, as well as any details that we're storing. So by default, I believe it's the transaction ID, the sender address, the amount, whether it's incoming or outgoing, and all just basic information that we need to calculate how much to send. So inside of the actual faucet, if we go all the way to the bottom here, all we're doing is we're calling this process funds, right? And so what process funds does is it will do a loop and then call itself when it's done, right? So in order to make sure that if the system crashes, so let's say you receive a transaction and its status is 0, which means that I've only received it, I haven't done anything with it. The next time the system loops, it will go through all of the transactions it needs to send that have a status of 0, and it will send it and mark it as 1, saying that it's successfully sent. That is how we're checking it or verifying that it's actually hasn't crashed and we're not sending multiple values to a person. And it does this every single loop. So it's gonna check for new transactions, which is where we're storing our transactions. And if we return true, then we're going to process the queue and then call the process funds. The reason why we are delaying here is because if we are checking for new transactions and we're sending, let's say, 100 people send us 5 ADA, we have to process those 100 people, and by the time it's done, then we're well beyond the point of this 10-second delay that we have specified here, most likely, and then we'll just immediately call itself again. We're not going to delay. Otherwise, if there are no transactions, it's going to wait for 10 seconds before it calls itself again. So that's the entire purpose of this, so that it's going to be continually looping through while it, and I mean, it can get overloaded, but that is a limitation of the network. You cannot send a transaction while there is a pending transaction on the wallet. That's because of an error that I will show you. And I talked about it in the V3 of the faucet where I explain what I've learned. But essentially, your currency or your ADA or whatever is outbound. It's already out. You haven't received the change or the remainder. So if you try to send, you have no funds to send. So that's and then it crashes. So that's the essentials of why this is an important function to wait for it. So let's go to process queue, and we'll pop into here. So in the process queue, this is, in case the system crashes and a pending transaction is there. We're not going to continue until all transactions are no longer pending, then we can start processing. So as long as we have a pending transaction, it's going to sleep and check it again until this returns false, and then it will, do its thing. So it gets like the transaction list, gets the template that we're going to use to send. It does a check if we're greater than max. We set it to the max so that we know how much to send, which is the 500 ADA worth. Anything over would just be 500 ADA worth, and it keeps the rest. And also, if it's anything less than, then we're just going to mark this as sent and ignore it because that's a donation. You sent like 3 ADA or something like that. We're just going to keep the ADA because you didn't read the instructions. So anyways, and then we have our token to send is the amount of the token according to this token value per ADA. And we calculate the ADA less fees divided by that amount, and that is the amount that we're going to send. And then our token template that we parsed from our template, we're going to, the quantity, we're going to set that as token to send, and then the sender is the sender address, which is on the transaction itself. We've already recorded that when we save the transaction, and yeah, and then it does its post, and it posts to the wallets with the wallet ID /transactions, passphrase from the config file, and then the payments, which is our body, gets sent in this payments section here, and then we have our headers, which is content JSON. And once it's done, if it's successful, we do this. Otherwise, if there's an error, it skips out. It doesn't mark it as sent because it crashed. So that's pretty much it. It will give you a log. You can add dates and stuff in here if you want later on. But that's pretty much it. You can look over the rest of it. It's all pretty simple. I think it can get kind of complicated for the sender and stuff like that, but it is very straightforward in the way that it looks for stuff. But that is the faucet. That is the code for a basic faucet to return some amount of a token for some amount of ADA. And that's what this entire project is about. So eventually, when everything is synchronized and the wallet is synchronized, what we'll do is we will get this running so that it at least checks for transactions, and we'll add some stuff in here just so that we can see that it's working. But yeah, we're not going to send any ADA to this wallet or anything like that. We're just going to have it check and stuff like that. I will leave the rest up to you guys on how to deal with that, because it could be anything. It could be a token, could be NFTs or whatever. But I will say this part here where we are sending the amount, This is where, with the third party thing, this is where you would replace that. So you would do a query to say NFT Maker Pro to send a random thing and give it the sender address. This sender address, you would rip that out. You would have your API key for NFT Maker, and you have your project ID for NFT Maker, where you have all your NFTs in, and you would just do the HTTP request as far as the API is concerned, the way that it wants it. And yeah, you just make sure that, I mean, we'll have the sender address that you need to send, and you won't have to deal with this token to send thing, because this will all be different since you're just sending a request, so you'll have to modify it a bit. But that's exactly how you would do it. You, instead of doing a wallet query, you would do an endpoint query to NFT Maker Pro. And I'll try to do a mock-up example of how that works when we get down to that point with the wallet. So all right, so the first step we have is make sure that we have our Cardano wallet version is correct, and it is. We are done. We are going to actually run this wallet service, the API for the wallet, and we will try to get this working properly and make sure it's all synchronized and all that fun stuff. So what we have is, I have a little bit of code here, and let's actually do a nano wallet API .sh, and we will paste this little bit of code in there, exit, and then make it executable, and this should run the socket. So we are on port 8190. So if we go open up a browser here, localhost 8190 wallets, well formed, or I won't be able to do it properly. Oh, v2. It's got a v2 in there. There we go. So now we don't have wallets in here, right? So what we need to do is we need to create a wallet. So I have a command that I've created, just a dummy wallet here. And we're just going to dump this in here. This is going to be our dummy wallet that is just for this purpose. We'll open up a new terminal here. We're going to paste this in. 8090? No, 8190. There we go. Alright, so now if I go in here and I refresh this, there we go. So there's my test wallet. It is synchronizing the whole wallet. So when this is at 100%, then we will be good to go. Okay, so now today is the first day back that I've gotten a chance to do this. We have a completely synchronized wallet. You can see the state status says that it's ready. And we have the wallet ID here. So we're going to copy this and we're going to put it in two places. The first one is going to be the transactions list endpoint for the wallet, for Cardano wallet. And we're going to replace this wallet ID with that wallet ID and change the port to whatever port we're on. We're on 8190 right now. And we also want to go into our configuration and we want to put the wallet in the wallet ID. So we've created the wallet, it's synchronized, and if we go and actually look at this raw data, you see that it's just an empty array. That's because there's no transactions on here yet. So as you send transactions, this will fill out, and then the system will it'll start, you know, populating and handling stuff as the transactions come in according to your settings. So now that we're in here, we need to install npm I and install all of our fun packages and stuff. And the first thing that you want to do is make sure that if you're going to do the token return, so you would in the configuration you can see it's like token value per ADA. So if you send 5, it's going to give you 5,000. It'll do this math here, and it'll send you 5,000 of a token, but you have to go and change your policy name or policy ID and asset name here according to your token. Send some amount of that token to this wallet that you have, that you created, and then it should be ready to go. We'll just go ahead and node test faucet, and it's starting up. So now what we can do is if we come here, we can start to see all of these GET requests. These are the requests that are coming in from the server, from our actual faucet. So all these new ones after this is going to be the system doing it, and it checks like every so often. It'll try to get them. So, but yes, the start time is created as of I don't remember. Is it like 10 hours or 12 hours ago or something like that? I can't remember. There's a time frame. You can change the time frame in there. But yes, it will do. Oh, yesterday, 5 hours ago. So it'll check it. 5 hours ago. But yes, that is the basics of setting up your faucet. It's running. Everything has not crashed. We are good. The transactions, you would just deal with the transactions as they come in. And from here, you just modify your sending method. And if you're not going to send a token, you're going to send NFTs or do an external supplier, that's where you would put that code. You would, instead of doing your sending information here where it does all this stuff for the transactions and reads the template and does that, would all get replaced with a sending to, say, NFT Maker Pro's API endpoint and give in the wallet ID that you get from the transaction and all that kind of stuff. You would just do that from here. So at this point, the faucet is functioning, and you just have to modify how you're going to send the data. So, yeah, I hope this answered any questions you may have. If you do have any other questions about it, make sure that you leave a comment below, and I can try to answer them as best I can. If it needs a video, I will put out an additional video out showing how to do whatever you have asked, hopefully, if it's not too complicated anyways. Beyond that, it's kind of up to you guys as developers to finish this project. So once again, thank you for watching and sticking with me. It's been a long week or so since I started this, and hiccups along the way, but if it went smoothly, it wouldn't work, right? Works first time. And yeah, so thanks for watching, and we will see you guys later.